going to discuss section 9.5, which is simplifying complex numbers. Complex numbers have to do with imaginary numbers, so it's mostly a review section. If you remember right, the square root of -1 is what we call I, an imaginary number. So therefore, I squared is equal to -1. Now this is all information that you should have had in Algebra 2. So I'm going to go through it rather quick, but you can come back and watch the video a second time if you need to. Let's say I have a power of an imaginary number. I have I to the 53rd power. There's several different ways to try and figure out what that's equal to. In my opinion, the easiest way is to always write it as a power of 2. So I raised to the second power raised to the 26th power, that's going to, when you multiply that, that's going to give me 52, but I have 53, so I would have to multiply that by another I. Well, I squared is equal to -1. -1 to the 26th power times I will give me the answer. If I have a negative raised to an even power, I'm going to lose my negative. So this is going to become 1 times I, or just I. So I to the 53rd power is equal to I. When you have a complex number, you have a combination of a real number and an imaginary number. This is the real part. This is the imaginary part. Okay? So when you have complex numbers, sometimes you're adding the real and the imaginary, and often the concept behind this, I also probably should say that this is in rectangular form. Eventually we're going to change this to polar. Okay, you're going to do math on your real and imaginary numbers or on your complex numbers. The easiest way to think of it is your I is like a variable. The only time it changes off of that is if you have I squared. That's the only time that it requires you to do something else. So let's say I have two complex numbers that I'm adding together. Okay, what I'm doing is I'm adding the real parts together and I'm adding the imaginary parts together. So I have 5 plus -2, which is a 3, and -3i and 4i is going to give me just an I. So that's going to be my answer to that problem. Now, if you have subtraction, just remember that you have to distribute your negative. Still going to do 10 minus 14, which is -4, but now I've got -2i minus a -6i. So when I add the opposite of the second number, I find that that's -2i plus 6i, which is going to give me -4 plus 4i. You can also multiply these, and this is where our I squared is going to come in. So I have 2 minus 3i times 7 minus 4i, and I'm going to have to do FOIL on this. So I have 2 times 7, which is 14. 2 times -4i is -8i. -3 times 7 is -21i. And last is going to give me 12i squared. Well, remember I said the I squared is the only time you have to worry about the variable being an I. I squared is equal to -1. So now all of a sudden, I'm going to combine those two. So I have -29i, but when I make that a -1, that becomes -12. So I have 2 minus 29i. You should never have an I squared at the end of the problem. If you have an I squared in your problem, you must convert it to a -1. All right, now I'm going to put some up here for you to try, so you can pause the video and come back. First ones are powers. And And then we've got a little bit of math to do. I hope you can still see the bottom one. -2 plus 4i and -2 plus 4i, just in case you can't see it. All right, do that and then come back to the video. All right, on this one, I would write it as a power of 2. So I have I squared raised to the 24th power, which is going to give me -1 raised to the 24th power, or just 1. This one over here is the same as saying 1 over I to the 86th power. So that's going to be 1 over I to the 2nd times 43. Because 2 times 43 is 86, so I have -1 to the 43rd power, so I'm going to keep my negative because that's an odd power. So I'm going to have 1 over -1, or my final answer here is going to be -1. On this one, when I add my real part, I have +1. When I add my imaginary part, I have -1. So it's 1 minus I. This one, 5 minus a -3, which is an 8, and 8i minus 1, which is a 7i. So your answer for your second one should be that. Then this one, multiplication, I have 4, because I'm doing FOIL, and I have a -8i on outside, -8i on inside, and a +16i squared at the end. Now remember, the I squared is going to change it to a negative. So I have 4 plus a -16, which is going to be -12 minus 16i. So that's going to be your last one. All right, now let's do a little division on these complex numbers. So I've got 5 minus 3i divided by 1 minus 2i. I can write it up and down. Now, if you remember back from Algebra 2, you are not allowed to have an I on the bottom. It's like having a square root on the bottom. So just like with the square root, with the I, you multiply by its conjugate. So I'm multiplying by 1 plus 2i on the bottom and 1 plus 2i on the top. I'm going to do FOIL on the top, which is 5 plus 10i minus 3i minus 6i squared. And I'll have to combine that in a minute. On the bottom, because I'm multiplying by the conjugates, I only have to do first and last, or Florida. So 1 times 1 is 1. -2i times +2i is -4i squared. So combining on the top, this, remember, is a -1. So I actually have 5 plus 6, which is an 11. And that's 11 plus 7i. Then on the bottom, this is going to be a negative, which makes this -4 times -1, which is +4. So I'm going to have a 5 underneath that. So your final answer there is 11 plus 7i divided by 2. All right, now you try one. Go ahead and work it, then come back to the video. All right, I'm going to write it up and down. I'm going to multiply by the conjugate. On the top, I'm going to do FOIL, so I have a -12 minus 9i plus 4i plus 4i squared. No, 3i squared, sorry. On the bottom, I'm gonna have Florida, so first and last, because they're conjugates, so I have 16 minus 9i squared. So when I combine my top, I've got negative 12 minus 3, which is a negative 15, minus 5i over 25, because that becomes a positive 9. Now, if I'm looking at this, and this, and this can all be divided by a number, I must reduce it. So I'm going to divide all of them by 5. So it's going to give me a negative 3 minus I over 5. And that's going to be my final answer. It must be reduced if it can be reduced. All right, your homework on this is page 583, 13 through 35, all. And that will be due at noon on Thursday.